Till now, we have seen the types of molding sand, the types of additives and binders, and we came to know a preliminary idea of how casting works. Now let's understand what are the important properties of molding sand. We have porosity, strength, adhesion, cohesion, refractoriness, collapsibility, and flowability. Let's discuss them one by one. First is porosity or permeability. It is the ability of the sand to allow the gases or air to escape from it. Or in other words, permeability or porosity of the molding sand is the measure of its ability to permit air or gases to flow through it. The molten metal always contains a certain amount of dissolved gases which try to leave when the metal solidifies. Also, when the mold is poured, water vapors and other gases are generated. And when the molten metal comes in contact with the molding sand and the core, again gases will be generated. If all these gases and vapors are not able to escape completely through the wall of the mold, they may penetrate the liquid metal, where after solidification they form gas holes and pores. And these gas holes and pores is what we call the casting defects. So to avoid these defects, the molding sand should have good gas permeability or porosity. The permeability varies with the composition of the water, as you can see in this particular graph. It increases up to a certain composition of water and then it starts decreasing. To identify the porosity of a particular molding sand, there is an experimental setup which we call a porosity test, in which, as you can see in this particular figure, sand is placed in top of a flask and a very small opening is there. Below the flask, gas or air is entrapped and we monitor the pressure of this particular gas or air using a pressure gauge. We monitor the escaping air, we monitor the pressure of the escaping air present in the bottom flask. This air is escaping through the small hole provided and towards the sand and then to the atmosphere. At a certain point, the pressure gauge, which is in turn monitoring the pressure of the gas or the air entrapped inside the flask. When the pressure gauge shows the pressure as similar to the atmospheric pressure, the experiment becomes over and we define an entity known as permeability number or porosity number, which is given by this formula VH by PAT, where V is the volume of the air or the gas that is entrapped in the flask. H is the height of the sand, which is generally 2 inches. P is the initial pressure of the air inside, and A is the area of the mold. Now the most important terminology, the most important component of this particular formula would be time. It is taken in minutes for the pressure to reduce to atmospheric pressure. The pressure that we are talking here is the pressure of the escaping air or the gas, and this pressure is monitored by the pressure gauge. Next we have the strength. It is the property of molding material that enables the pattern to be removed without breaking the mold and to stand the flow of molten metal when it rushes inside the mold. Obviously, the molten metal is having very high extreme temperature. The strength of molding sand also varies with water composition, and it is found by various experiments, various practical applications that at 3% of water composition, all the molding sand have the maximum strength. And this is purely empirical. Empirical means everything that is shown here is depend upon practical applications. It depend upon practicals performed in lab. There is no theoretical backup for the same. Now the strength are of two types, green strength and dry strength. Green strength being the strength of the green sand mold and the dry strength of dry sand mold. Next we have adhesion or adhesiveness, which is the property of sand mixture to adhere to another body. The another body is nothing but the walls of the molding flask. The molding sand should cling to the sides of the molding boxes so that it does not fall out when the flask is lifted or turned over. And hence it is also dependent upon the type of binder used. Then we have cohesion. Cohesion is the property to stick with similar material. Sometimes in certain books, cohesion and strength are considered as the same entity. Next we have refractoriness. It is a property to retain the strength at extreme temperatures. It is the ability of the molding sand mixture to withstand heat of melt without showing any sign of softening or fusion. It is completely dependent upon the purity of sand particles and their size. Next we have the collapsibility. The collapsibility is the ability of the molding sand to collapse. It is in turn needed for easy removal of casting. And it is also needed to avoid heat or hot tears, which is a casting defect generated due to thermal stresses. And it is also needed to avoid cracks in the molding sand. And last but not the least, plasticity or flowability. It is the measure of molding sand to flow around and over a pattern during the ramming process and to uniformly fill the flask.